Yo, 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 yo. Okay, scatter plots. We're going to go over a lot of vocabulary terms, but overall it should be a pretty simple lesson. So let's get straight to it. A scatter plot is a graph with points plotted to show the relationship between two sets of data. And we will show multiple examples of what a scatter plot is, but they look like this. So when we have a bunch of different data points, they're not necessarily in a straight line. Um, and they might be all over the place, but this would be a scatter plot, a bunch of data points that are recording two sets of data. Now, a cluster in a scatter plot is a closely grouped set of data. So if I have a scatter plot, a cluster is when I have a lot of data. These are all different points in a scatter plot. So this right here would be a cluster of data. It's a lot just in one little section. An outlier is a data point that is very different from the rest of the data. So all this is kind of trending upwards, but then we have like this random point over here. This would be considered an outlier, or maybe like one up here. Doesn't really fit with the data. And then finally, association describes how sets of data are related. And that's where we get into positive, negative, and no association. This is kind of goes along the lines with slope. So data set with a scatter plot will have a positive association if it's trending upwards or has a positive slope. If I were to draw a line through it, if I were to draw a line, try to draw a line that goes through this data, that line would have a positive slope. So that means it has a positive association. As one increases, so does the other. It's going down as one increases, the other one's decreasing. That is when we have a negative association. So negative association, as my x values increase, my y values are going down. They are decreasing. That's a negative association. And then finally, no association is one set of data, or the x's and the y's have nothing to do with one another. And we'll talk about examples like in real world problems and what has no association, positive and negative. So here we go. So with scatter plots, it's when we collect data, and a lot of it's done through surveys. So like Susan asked 20 people if they would buy a new product if she developed at each of several prices. A product that she developed at each of several prices. The scatter plot shows how many of the 20 said yes at a given price. Describe the association. Okay, so we want to know how many buyers of all the people she asked, how many buyers said they would buy it at a price of $2. Would they buy this product at $2? And all 20 people said they would buy this product at $2. Well, then only looks like not as many people. It looks like only 19 people said they would buy it if it was $4. And then only 17 people said they would buy it if it was $6. And then at $8, it went down quite a bit. At $8, only 13 people said they would buy it. At $9, she said, if I price this product at $9, only 8 people said they'd be willing to pay $9 for whatever it is that she is trying to sell. And then if she priced it at $12, I'm sorry, this is 10. My apologies, this is going by 2. That's $10. Whoops. Okay. And then at $12, only 2 people would be willing to buy it because this is going by 2s. So those are all the data points. She said she's trying to figure out what price should she sell this product so that she can make the most amount of money. So she's doing a survey to figure out, maybe if I sell it for, I don't know, $8 and I get 13 people to buy it, and then 8 times 13, and that's going to tell her how much money she makes. Well, she sets it at $10. 10 times 8 is $80. That's how much money she'll make. So she's trying to figure out what's going to give her the most amount of money. So here's my scatter plot. What we want to do is we want to describe the association between the price and the number of buyers. So here are my two different things I'm comparing. I'm comparing the price of the product and how many buyers there are. Well, as the price is increasing, the amount of buyers people are willing to buy it is decreasing. So this has a negative association because as the price increases, the amount of people that are willing to buy decreases. And this is how it is with most things. The more expensive something gets, there's a less amount of people that are willing to pay that price for that expensive item. So this has a negative association. As the price is increasing, the amount of buyers are decreasing. If I were to try to draw a line that shows a direction, it looks like it's going down. So therefore, it is a negative association. Sometimes you'll have to create your own scatter plots. So we'll be given a set of data and we have to plot the data. So he recorded his height at different ages. The table below shows the data. Okay, so Bob recorded his height at different ages. So at 6 years old, Bob was 45 inches tall. So at age 6, he was 45 inches tall. That is this point right here. Okay, and I got to plot all these points. At age 8, he was 50 inches tall. Age 10, 55. Age 12, 61. Now 61, we don't have a perfect point for 61, but it's basically right there. We can do a rough estimate. And then 14 years old, he was 63. So there's my data. So it's not a perfect straight line, but there's my data. Now we want to, so we made the scatter plot. So if I were to describe this association, this would be a positive association. Because as he got older, he got taller, which makes sense, right? As a person gets older, typically speaking, they get taller. So as one increases, the other one increases as well. Now at some point, it's going to stop when we stop growing. But with this particular data, we have a positive association. So these are what we're going to be asking. We're going to be asking as a negative association, positive association. Are there outliers? Are there clusters? There's no outliers here. All of this is trending in the right way. It's all going in the same direction as the rest of the data. Same thing down here. It's all decreasing. So there's no outliers. There's no random points that are like all the way out here. Okay, so here's what I want you guys to do. For this problem right here, I want you guys to plot these points and to create your own scatter plots. I want you to pause it and plot all the points, create your scatter plot. And we're going to see if there's any type of association between the number of hours spent studying and someone's test grade on a math test. Okay, so go ahead and pause this video and try creating your scatter plot. Go. So this is what your scatter plot should look like. So a couple things I wanted to point out about this graph is this counts by fives. It's 50, 55, 60, 65. This counts by 1/2, because we see we have a halfway point and then we have 1 hour. Halfway point, 2 hours. So this would be 1.5 hours, 2 hours. Well, I mean 0.5 hours. So like at 0 hours we got 75, 0.5 we had 80, 1 hour we had 80. And also it's okay to have 2 points on the same thing. So like one person spent 1 hour studying, they got an 80. Another person spent 1 hour studying, they got an 85. That's okay. One person spent an hour and a half studying, they got an 85. Another person got a 95. Okay, so this just shows this is our scatter plot though. So now what trend do we see in the data? So we want to see, well, what do we notice here? With all this data, what's the trend? Well, one, this is a positive association. The more time spent studying typically meant the better the grade. Not always, but most of the time. Like this person right here spent the most time studying, there's still 2 people that got a better grade than them. So this is not a guarantee, but typically the more time someone spent studying, the higher the test grade. So that's what we know. That's what we can say we also notice. You might have to make actual statements here and say, well, what trend do I see? The more hours studying, the higher the test grade. And that's what we use scatter plots for. We try to figure out what's the trend here, what's going to most likely happen. It's not a guarantee, but what's probably going to happen. And this makes sense. More time, if people spend more time studying, they're probably going to get a better grade. And this is data to show that correlation and how and that association. Okay, that's it. So things to remember: positive and negative. Okay, and then that's all I got for you guys. So if you guys have any questions, let me know. Here is your independent practice. Here if you have a scatter plot, describe the association and give a possible reason for it. So just like we said, every single thing that we've talked about, we've kind of discussed the possible reasons. For like this one, we said, well, if you typically spend more hours studying, you're going to understand the material better more, so you're going to get a better grade. So that's why it has a positive association. So I want you to also give me a reason for this data right here. Okay, guys, thanks for watching. That's all I got for you guys. Gradius out.